There's a lot of factors going on, but at its core, because you have certain components of the antennas, like the thermocouple, that use what's known as the Seebeck effect. And when dissimilar metals of different temperatures interact, touch each other, and arc together, they create feeble voltage, 30 millivolts. That goes into the system every time the temperature is variant, like 10 degrees cooler or hotter. So you have those kind of other functions that are just directly producing feeble voltage, but at its core, it's electromagnetic induction. And I proposed that to him, and he thought for a minute, and he was like, "That's it. That's what you're doing. That's electromagnetic induction at its most just elegantly simple form."
And on these, I mean, they don't look too long. How tall is one from tit to 2 feet?
The antenna itself.
Yeah.
So the antenna body is based on all the measurements on these devices are based on the sacred cubit, so that the biogeometry of the device is just in a static position. It's harmonious. That's just a little bit of something that's a proprietary addition. None of the original antennas included that type of thought, but I wanted the intention and the thought on every single piece to have a function and a purpose. So the body of these antennas is half sacred cubit, which is 10.30 inches.
And then that includes the little rods up top?
That's just the body. Then the rods extend to make the whole unit itself. I see what you're asking, is approximately 2 feet tall.
Okay. And then again, I'll put a picture up on the screen here for people who are watching this. At the bottom,
that's the lead wire.
Okay, lead wire. I was going
to that you would connect your ground wire to with a coupler.
Okay. So that you wouldn't install this directly into the ground, would you?
No, that goes 25 feet up on a pole.
And then so a wire runs off the bottom of that, and then the wire runs down,
goes down the pole through ceramic insulators or other type of insulators, traditionally ceramic, and then into the ground. It's a varying depth between, let's say, 10 and 16 inches, depending on how deep your tillage is going to be. If your tillage is going to be at 10 inches, you're safe to put it at 12 or 14 inches. So you can kind of see what I mean. It's the depth. You just want it to be in the rhizome layer of your plants, basically.
So I'd say, okay, antenna relatively small. If you grew up in the 80s, you've seen the old school satellite antennas.
Oh gosh,
10 feet across, right? So
this is nothing like that.
That's a satellite dish. This is small. So how I say that because you have what I would visually say is a relatively small receiver.
Mm-hmm.
But I mean, we look at our iPhone, right? Like there's no antenna
there. Yeah. Size is not
necessarily an indicator of potence in many ways. How big of an area could one of these cover?
Okay, that's easy to answer. Infinite distance south to north, because that's how you run the wire. You can run that wire if you had a 20 feet approximately east to west. These are all installed. The lines will always run south to north in these systems, regardless of if that's a diagonal line or if that's straight in line with your crops. They need to flow with the telluric current. Telluric current flows through air, land, water, concrete, everything.
The brass, magnetic north,
magnetic south to magnetic north. Exactly. Magnetic. Because in the old days, direction orientation is based off the term orient, which means east. And so you would determine your direction from the rising sun. So that's actually a variable condition. So we use magnetic north to south. That's correct. So you check it with a compass.
Does the soil have to be wet for this to be effective? I ask because, drier climates like I'm in here in Southern California. I mean, if you're not irrigating, the top layer of soil can just totally dry out.
Totally.
And I think, okay, no water, no conductor of electricity. Is that valid or no?
It is valid to a point. It will work without it being constantly wet. Most certainly. It will actually, electrolysis produces its own moisture. So factor that in. Also, when you organize the molecules in the soil, the ionization, the organization, the structuring, you have a porosity and a soil texture that holds moisture better. I have farmers that have been farming in this region, literally like next door to me and down the road for much, 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 much longer than me. And they come and they grab the soil And these are traditional farmers that use big disc plows and stuff like that. And they come and they grab the soil, they don't recognize it because the porosity, and it'll have just rained like 7 inches. Let's say we get a lot of rain. It's raining today. We get a lot of rain. And the soil will be like wet, but fluffy. It has porosity, but also retains water well. It's because it's structured. It's structured from the electricity.
And part of that is you have a two, you're not, you kind of have a two-part solution. You apply the basalt rock dust to the
With
soil,
compost.
so through the compost. So you have a media that's primed per se to accept the tool, where if you just apply the tool, the regular soil, not necessarily as effective.
Sure. I mean, that's kind of like saying, like, why wouldn't you do everything that would be in your favor?
Okay.
So, like, like I own a paper pot because it's awesome for a handful of my crops. I don't know what I would do without it at this point. But that doesn't mean that it takes the place of some other stuff or that I
Right.
wouldn't have something else because I have the paper pot that is also effective at its job, if that makes sense.
Absolutely.
So it's a tool, and you install these systems. After they're installed, there's no maintenance. So, for a farmer, you're like, well, I install this. You're going to use way less inputs. You're going to have all this nitrogen become available. You're going to not have that ammonia locked up in your soil. You're going to, if you want to even get into the deeper levels, you're going to support the industries of death and war less through needing less of those materials. Um, you're going to structure your soil for better water retention, porosity, and also create a level of moisture with the electrolysis going on in the soil. So that's to speak on dry soil. But yes, moist soil is going to always conduct electricity better, for sure.
Can't find the picture now, but I was looking at one of the ones you installed, and it looks like you dug a trench, you lay the wire into
Uh-huh.
the trench, and around the wire there was some sort of
Magnets.
packet. Okay, yeah. What's going on there?
So those are magnets that are in phase or stacked the same way. Um, thickly coated in beeswax. Those are ring magnets, so they have a hole in the center, little donut magnets. There's 6 of them in the stack, and then they're coated in beeswax thickly just to protect them, basically. And also, the center gets coated and filled with beeswax. So when you slip your ground wire through those magnet stacks through the center, they are around your ground wire in periodicities down the line. There's no exact rule of how often to put them. I put them as often as I can. Like, it's kind of one of those things, like the more the better. So if you have 100-foot ground line, it'd be great if you had 20 on there, but if you had 5 on there, that's awesome too. It's just the more the better because that's just more electromagnetic induction. That's more magnets interfacing with the conductor hooked to a positive and a negative, which is fluxing. So you're just getting more inducted voltage down your line when they're just to boost the system.
And it's essentially, and
I'm combining that. That is not from traditional electroculture from the 1800s. Some people call those earth magnets, and they're used for what I'm using them for, but I'm using them on the ground lines with electroculture systems. Just combining things that are all benevolent and harmonious.